Hey guys, today we're going to talk more about triangles, but we're going to specifically talk about isosceles triangles and equilateral triangles. So we're going to start with some isosceles triangles, and first I'm just going to draw an isosceles triangle over on the side here. So remember, an isosceles triangle has two congruent sides. And now we're going to talk about parts of that isosceles triangle. So an isosceles triangle has legs. The two legs are the two congruent sides of an isosceles triangle. Okay, so this right here is a leg, and this is a leg. The two congruent sides are called the legs. The vertex angle is the angle formed by the legs. So where they come together right up here is the vertex angle. Okay, next we have the base. That is the third side. So we've already talked about the two that are legs. The third side is called the base. The third side of an isosceles triangle is called the base. So here is the base. The base angles are the two angles adjacent to the base. Okay, so along the base we have two base angles, right here and right here. Something we need to know about the base angles of an isosceles triangle is that they are always congruent. So if two sides of a triangle are congruent, then the angles opposite them, which are called the base angles, are congruent. Okay, so here I have an isosceles triangle. If these two sides are congruent, then these are the legs. The two base angles across from those sides are also congruent. So if side AB is congruent to side AC, then angle B is congruent to angle C. Okay, now if we follow that logic, then if we have a triangle that is equilateral, so all three sides are the same. So if a triangle is equilateral, then it must also be equiangular. So all three angles are the same. If all three sides are congruent, then all three angles are also congruent. Okay, so the converse of that is also true. So if two angles of a triangle are congruent, and I'm just going to put the symbol here, if two angles are congruent, then the sides opposite them, called the legs, are also congruent. So if I have a picture like this and I've got two angles right here congruent, then I know that these two sides must be congruent. So if angle B is congruent to angle C, then side AB must be congruent to side AC. And if a triangle is equilateral, if a triangle is equiangular, then it is equilateral. So if you see a triangle like this, all three angles are congruent, then you know all three sides must also be congruent. An equilateral triangle is always equiangular, and an equiangular triangle is always equilateral. Name the congruent triangles, the congruent angles of triangle FGH. So FH and GH are congruent sides, so those are the legs, which means this right here is the base, and it's the base angles that are congruent. Angle F must be congruent to angle G. find the measure of each angle of triangle RST. Okay, so the clues we have are that all three sides are 3 meters long. So these three sides are congruent. So this is an equilateral triangle, which means it is also equiangular. Now we learned in our last lesson that these three angles have to add up to 180 degrees. So if I do 180 divided by 3, since they're all going to be the same, then I'll get that measure. So 180 divided by 3 is 60. Okay, so I know that this is 60 degrees, this is 60 degrees, this is 60 degrees. In an equilateral triangle, the angle measures are always 60, 60, 60. So the measure of angle R is 60 degrees. The measure of angle S is 60 degrees. The measure of angle T is 60 degrees. Find the values of X and Y in the diagram. Okay, so I have a triangle right here. This outer triangle, JKL. So this triangle is equiangular. I've got an arc here, here, and here. It is equiangular, which means it is also equilateral. Okay, since it is equilateral and side KL is 8, then JK is 8 and JL is 8. X is alongside JL. I know this has to be 8, so X is 8. Now this smaller triangle here, MJL, has 2 arcs here and 2 here. Its base angles are congruent, so it is isosceles. So these two are congruent. So I know that these two sides have the same length. So 2y and x are the same. So 2y equals x. Well, we already know x is 8, so 2y equals 8. And we can divide by 2 and get y is 4. If segment FH, so this segment right here, is congruent to segment FJ, then what angles are congruent? So we're talking about this bigger triangle. These two sides are congruent. It's isosceles. This is a leg. This is a leg. It's the base angles that must be congruent, and the base angles are right here. Angle H is congruent to angle J. And for the rest of the way, we are going to be solving for some variables. So in number 3 here, I have an isosceles triangle. And in an isosceles triangle, the base angles, so here's the base angles are congruent. So 2x plus 3 is equal to x plus 8. So I can subtract x from both sides. I can also subtract 3 from both sides. And I get 1x equals 5. So x is 5. Now in order to get y, I'm going to need to find the length of both of these sides. So 2 times 5 plus 3 is 13. So this angle is 13 degrees. It looks a lot bigger. Clearly it's not drawn to scale. Okay, so if x is 5, I've got 5 plus 8, that is 13, so that's good. I should get those two having the same measure. So both of those angles are 13 degrees. And now I can add the three angles together. So I've got 2y plus 13 plus another 13. And the three angles of a triangle always add up to 180 degrees. So that's 2y plus 26 is 180. I'll subtract 26 from both sides. 180 minus 26 is 154. 2y is 154. And divide by 2, and I get y is 77. So I've got x is 5, y is 77. All right, we learned that the exterior angle of a triangle, we learned this in the last lesson, is equal to the sum of the two remote interiors. Unfortunately, I've got variables on all of these and they're different. I've got a y and I've got two x's, but here's something else I know. This angle right here, or these two angles right here, are congruent to each other. Okay? Because this is isosceles. This over here is the base. The base angles are congruent. So I know that this angle right here is the same as 2x plus 20 degrees. Now I can add the three angles of this triangle. 3x plus 2x plus 20 plus another 2x plus 20 equals 180 degrees. Okay, now I will combine like terms. 3x and 2x is 5x. Another 2x is 7x. 20 and 20 makes 40 equals 180. Then I will subtract 40. 7x equals 140. And divide by 7. Okay, so 140 divided by 7 is 20. So x is 20. Okay, now I can plug that in right here. 2 times 20 plus 20. So that's 40 plus 20. So that tells me this is a 60-degree angle. Which means this, by the way, is also a 60-degree angle. Which means this is a 60-degree angle. And now I have here an exterior angle and an interior and exterior angle are a linear pair. We learned that in our last lesson. So they add up to 180. So 60 plus y is 180. And then I can subtract 60 and I get y is 120. And for my last problem, I've got an isosceles triangle right here. And here's the base. These base angles are congruent. 8x plus 12 is equal to 4x plus 20. Minus 4x and minus 12. And I get 4x equals 8. And I divide by 4, and I get x is 2. Okay, now I can plug that into both of these. Hopefully they'll be the same. So I have 8 times 2 plus 12, 28 degrees. And I have 4 times 2 plus 20. Also 28 degrees. Okay, now I can use those to find this angle right here. So I have a total of 180. So 180 minus 28 and minus another 28. Gives me 124. So this angle right here is 124 degrees. Now these two are a linear pair. So 180 minus 124 is 56. So this angle is 56 degrees. Now I have another isosceles triangle, and this is the base. And those base angles are congruent. 4y is equal to 56. And I can divide by 4. 56 divided by 4 is 14. So I get y is 14.